Good morning, ladies and gentlemen. Light rays along the radius of a spherical concave mirror reflect back along the same line.
Yeah, if a light ray passes through the center of curvature, it's going to hit the mirror and go right back along that same path because the radius is perpendicular to the tangent.
I like this, right?
Yep.
Yeah, okay, cool. All right. Test to see if your diagrams are correct. Draw a line from the tip of the object through the C. It should pass through the tip of the image. And I have a few of these from in class that I did. So these were the ones that we did yesterday in class on the board, but I did them on paper as well. And yeah, nothing on the board to work. And draw it from the tip of your image through the center of a curvature. And this point right here is where that arrowhead should be.
Yeah, that's a miss.
And I noticed I said, eh. Not very good here. Now check this out. Nice, I did a good job here. From the tip of here through the curvature down to there.
Yeah, so just to review, you send one in parallel to the principal axis. It goes back to the focal point. And one that comes in through the focal point reflects back parallel to the principal axis. So that's where and this is just the check line that lets you see if you did it right or not.
And you know, why was one of these better and one of these not? Well, it comes down to how precise are you measuring those distances, right?
That's right.
And this was from the actual homework. We probably already went over this. I forgot to do it for this one, so make sure you.
Well, it
Oh yeah, that's why I did. That's why I didn't do it. Sorry, I'm not looking here. Yeah, so I was like, okay, well, boom, I nailed this one. Look at that. Look at that precision right there. Okay.
That's right.
And then I drew my ear in the wrong spot for this one. Checking this one, not bad at all. That first one, my first one was a little bit of a.
But see, that's the way life is. It's very difficult to be exact and precise and perfect.
And then you get better, right?
Yeah.
Okay, so you've done that check, and now behold the mirror equation.
So here's a way to locate the image mathematically.
Okay, 1 over x, 1 over the distance of the object plus 1 over the distance of the image.
So what we've had the focal length and the distance to the object, and we've used a ray model diagram to find the distance to the image. How do we solve this for the distance to the image?
Let's do that on the board, yeah?
Yeah.
Okay, so I'm just gonna subtract this over here. And what I'll do is I'll say 1 over this minus 1 over this, and then I'll get an answer. Then I do x to the negative.
Yeah, we're not going to solve for that. We're not going to do all
We're
that.
not gonna actually do all this.
Lowest common denominator
Yeah.
crap back with that.
Terrible. Okay. All right. So go ahead and find your Get Real lab here. Okay.
Well, let's look at the example problem first.
Oh, the
Is
sample
the example problem next?
No, we were talking about doing the Get Real calculation.
All right.
For the focal point. Oh, for the focal point.
Well, no. Let's calculate what our answer should have been for our ray model diagrams.
Oh, yeah. Sorry. No, that was my number one there. Okay. Yeah. So I was thinking about the check thing that we just did. Okay. So take out your homework, not your Get Real lab. We'll get that later. And I want you guys to calculate.
Well, let's do the first one for them.
Oh, okay, we'll do it with them. So the distance of the image. So 1 over di is going to equal. Now, what was my focal point? It's 6 centimeters, right? 1 over 6 centimeters minus 1 over my distance of my object was 12 centimeters there. You want to do this one? No, we can do this one.
Oh,
we
sorry,
do-
I picked up the wrong page. Well, as long as you've got that,
Yeah, we'll
I
do it
can
there.
tell you what the answer is going to be.
Yeah.
It's going to be 6 centimeters.
Yeah. So do you want to do that one or do we want to do?
We already got it on the board.
Yeah. Okay, let's go ahead and do. Let's do
Here,
the.
I'll hand this to you.
Yeah, we'll do this one right here, the 14 centimeter one. Okay, so we'll put 14 centimeters right here. That's the distance of the
To the
object. There we go. Sorry, I flip-flopped these. Okay, so here we go. So we're gonna do 1 divided by. Wait, we do x to the negative 1, right?
Yeah.
6 x negative 1 minus 14 x negative 1 gets me my answer. Am I done yet? No. X negative 1, and I get 10.5. So
10.5, and what do we come up with? 11 centimeters.
not
That's
bad.
pretty good.
Okay, and then let's go ahead and check our next one. So the only thing we're going to be changing here is the 16, right?
Yeah, it's 16 centimeters.
Okay, so let's make this 16. So we'll do 6x to negative 1 plus...
No, minus.
Oh, sorry, thank you. Delete. Okay, so minus 16 x negative 1. I get my answer. X negative 1. I get 9.6.
9.6, and you got 9 point. What is that? A 4? 9.4.
9.4. Dang.
Ba-boom!
Good. Okay. All right. Cool. Isn't that a lot easier?
It is.
Okay.
How about this one right here?
Okay, so I'm gonna do. Let's see.
The distance of the object
10.
was 10 centimeters.
Okay, so 10 now. Okay, so x negative 1 minus 10 negative 1 equals negative 1 equals 15.
15, and you got 14.6, which
Not
is pretty
bad.
darn good.
Yeah.
Anytime in a high school classroom where you're within 10%, that's good work.
Yeah, I want to see what this 14 one. Did I already do the 14 one? Oh yeah, I did. Yeah.
Yeah.
Okay. All right. That's the one I didn't really do very well. It was the one that I think was probably the most off. Okay.
All right, now we do the get real thing.
Now I've got the get real thing. Okay, so now for this, take a look at this. We measured, we had the distance, the object's distance, 15, 20, and 30, and then we had the image distance, which we measured.
Yep, and
Right.
so now let's calculate the focal point. We can solve this equation for the focal point, or the focal length.
Okay, well, that's pretty easy because it's just there, right?
Yeah.
Okay, so shall we put in our numbers here?
Here's your data.
1 over the focal point equals, okay, we'll do this first one, 15 and 130. Okay, so,
Well,
right, is that right, Boyan?
no, let's just,
The distance of the object being 15?
yeah, at 15 centimeters, the distance of the image was way out there.
Okay, plus 1 over, I think it says 130 centimeters, like that, yeah.
Yeah, it was over a meter. Remember, we had
Yeah.
difficulty measuring
We
that
were
one.
like, oh.
So this one's probably not going to be real good.
Okay, so 15, negative 1, plus 130, the negative 1. Okay, negative 1, I get 13.4, I'm gonna call it 13.4. Okay, and what was it supposed to be?
Well, we don't
we
know
have to
yet.
come back, yeah, we'll come back to that. Okay,
And
so
then
that's our
the-
first one.
The next one, the distance to the object was 20 centimeters.
Okay,
And the distance to the image was 45.
45 centimeters. All right, so sorry, wrong. I don't know why I can't remember the x to negative 1 today. Plus 45 x to negative 1, and I get, not that, I get 13.8.
Whoa, that's actually pretty close between these two.
Not bad. Okay, next one.
The next one, the distance to the image is 30 centimeters. I beg your pardon, distance of the object is 30, distance of the image it looks like 25. I think that's a 25.
Sure is. Okay. What is this? What is this right here? Oh, that's this. Sorry.
That's the height, we'll get to that
I
in
was
a
like,
minute.
wait, hold on. Okay, so 30, negative 1, plus 25, negative 1, and it's not the answer, and I get 13.6.
13.6.
Sweet.
You know, there's a way to confirm this. We
Let's
could
go
take
out.
this outside and do like what we did yesterday.
Okay. Alright, so we can go ahead and tell them what you're gonna do here. Ah, I always do that. Is it working? Check.
Yeah, it's working. And get it the smallest you can. That's big, that's big. Smaller, no, out.
Yeah, that's what I was thinking. Right, like right.
There.
Yeah, right there.
See, that's a little more than 13 centimeters.
Okay, so that's not bad. Now, what Blinky was telling me to do is you wanted to get it the brightest, but also the smallest.
Yeah, well,
All the rays
it
are
focuses the image of the sun into the smallest little tiny thing.
And what did you say it was, Boykin?
Oh, it was over 13. It was between 13 and 14. So
Okay, so not
that's
bad.
Not bad.
Wow. Okay. Yeah. I'm really looking at that. Whenever I look at it now, I'm just a little like.
Just
okay.
dazzling.
Now, did we hit everything? Yes,
We did.
Okay. All right. The magnification. Oh, so new idea here. Okay. Magnification compares the size of the image with the size of the object.
if the height of the image is the same as the height of the object, the magnification is 1.
Yeah.
If the height of the image is larger than the height of the object, it's greater than 1. If it's smaller than the height of the object, it's less than 1.
The magnification depends on the relationship between the distance of the image and the distance of the object.
Yeah, and we saw that in this lab where we were able to measure the image size. And so the distance, as the object changed, then the image changed.
Okay, so we can put them all together and we get, voila,
Heidi Hodo.
Heidi Hodo. Now, why is that negative? The
Well,
image.
yeah, because magnification, if the image is inverted, then the magnification will be negative.
Okay, I think we're going to come back to an example of that.
Yeah.
So the idea is we typically have an inverted image right there, and that helps communicate that.
Let's calculate, how could we get the height of the image from this? Select one of our diagrams that we made yesterday.
Let me go ahead and get rid of this here. Okay.
Boys and girls, which one should we do? We won't do the 12 centimeter.
Yeah. So let me read this equation on the board real quick. I D O
Heidi Hodo.
All right. So from this one, so we should do this one then.
Yeah,
Okay.
sure.
And what are we wanting to solve for?
We want to solve for the
distance of
height of the image.
Oh, the height of the image. You see how we did here. Okay.
So if we want to solve for high, we multiply both sides by ho. And what you get is ho-de-do.
Yeah.
Ho-de-do.
Oh, it's right over here. Okay, so we want to get this by itself. Okay, like that. Okay,
Yeah.
sweet. All right, so let's go ahead and plug the distance to the image in. We're doing this one, right?
Yeah, and I just realized it'd be good if we still had those numbers from the previous.
Oh, from which one?
Let's use this one because that came out pretty good, right?
Or do you mean the Get Real?
Well, we'll do one of both.
Yeah.
Let's see. This one looks like it's closest, the most accurate.
Yeah, it was 9.6.
Okay.
Yeah.
All right, so the distance to the object is 16 centimeters.
Okay, so
that's
down
on the
here.
bottom. 16 centimeters. The distance to the image was 9.6.
Yeah.
And the height of the object was 2 centimeters.
Yeah. You guys with us? Okay, why we chose this one, you know, when we just did our measurements previously, and we got the actual, what the distance of the image was supposed to be.
Yeah, she got 1.15 centimeters. Let's see what it should have been.
All right, so that looks ugly. All right, so I'm gonna do negative, so when I plug this in my calculator, I'll do the negative 9.6 divided by this times that.
Yeah.
Divided by 16, okay, times 2. And I get negative 1.2.
1.2, and that's
Oh,
very.
I forgot my negative right there. Okay, so it's just 1.2.
No,
sorry.
it's negative 1.2.
Oh, no, you're right.
Because
You're right.
because the object is upright, that's positive, and the image is inverted, that's negative.
Yeah. And what did I say the height of my image was? Oh, 1.15. Now, how much more can measure with that much accuracy? I don't know.
Must have been luck.
Yeah. So 1.2, negative 1.2, negative tells me it's inverted. Sweet. Okay.
So now let's use one of these from the Get Real lab.
Okay, so the hoe is going to be our negative distance to the image. Which one do we want to use?
Did we measure the height of the L?
We did right here, 3 centimeters. Let's do this
No,
one.
that's the image.
Oh. Ooh. Do you have it? I think we do.
In search of the letter L.
I think I'm going to show the AP kids your in search of sound thing just to show it to them.
Okay.
I know. All right, so
The height of the image.
wrong side. So we'll call that
1.3,
1, 2, 3.
1.2.
Yeah, let's do 1.3. My eyes are playing tricks on me here.
1.25. How's
Yeah,
that?
1.25. So that was 1.25. That is the height of the image.
Image.
Okay. And then the height of our object, we'll do this
No,
middle
no, no,
one.
no, no. The height of the object is 1.25.
Oh, I'm sorry. The height of the object here. Oh, thank you. Okay, height of the object.
The
Okay.
distance to the image that we got was 3 centimeters.
3.
Was that? No. 45 centimeters.
45. Geez, it's hard.
That's my bad.
This paper, I'm telling you, it's kind of hard to look at. I don't know what the deal is.
And the distance to the object was 20 centimeters.
20 centimeters. Thank you, Boykin. Maybe it's Friday. Okay, so
That's our excuse for sticking with it.
negative 45 divided by 20, and then times 1.25.
Yep.
And I get negative 2.8. Huh.
And we got negative 3.
Height of the object is
Well, you wrote down positive 3, but if you recall, the image was inverted. It was
yeah.
upside down.
That's important.
All right.
Okay. Not bad.
I think
at
that's
all.
enough of this stuff.
Okay, moving on. Example problem 422. It's right here. Okay, so here's an example of how to calculate a real image. Real image formed on this that could be projected on a screen,
Yep.
formed by a concave mirror. And go ahead and read through this and see if you can, answer the question.
So the radius of curvature is 20 centimeters. So that's C. What would F be?
It's gonna be half that, right?
And the object is 2 centimeters high. Okay, that's how the height of the object, and is placed 30 centimeters in front of the mirror. So the distance to the object is 30 centimeters. Go ahead, calculate first the location of the image, and you should get a number between 10 and 20.
Mm-hmm.
So calculate the distance to the image, and then calculate the height of the image, and it should be smaller. It should be less.
It should be negative.
Yeah.
Okay.
So go ahead.
Do it.
Pause this
Pause it,
and
do
do it on your own bad
Where's
self.
Chapter 18. Alright. Alright, compared to the object, the image is either upright or inverted.
So when we describe an image, there are 4 things that you got to have. And one of them is it right side up or is it upside down?
Yeah. Right side up, upside down. If the image is in front of the mirror, it is real. And so you can see here that the image is in front of the mirror. This is the mirror, it's in front of it. It's
Yep.
a real image. It can be projected on a screen.
Yep.
It's real. If the rays converge only behind the mirror, the image is virtual. Notice how this is the mirror. This is the image is behind
Yep.
it.
Yep.
Okay. And we have an example problem on the next page. Go ahead and read through this example problem. A concave mirror as a magnifier.
Let's just go ahead and try
Wanna do
this. Let's locate the image and let's get the height of the image as well.
All right,
so-
go ahead and read it to me.
Height of the H sub O is 2 centimeters.
Okay.
The D sub O is 5 centimeters.
All right.
Focal length is 10 centimeters. So that's in between the focal length and the mirror. And this shows where the object is located, where the image is located and what it is. So, okay, so now let's solve for the distance to the image using the mirror equation.
Okay, so wants
1
to know
over
if
F
this
minus 1 over D sub O.
equals 1 over d sub I. So that's going to be 1 over the focal point, which is 10,
Yep.
minus 1 over the 5 centimeters.
And I notice right now that 1/5 is larger than 1/10, so we're going to get a negative number, and it's going to be negative 5, I'll bet.
10 to the negative 1 minus 5 to the negative 1 equals, equals negative 10.
Whoa!
Okay, so this is going to be negative 10 centimeters. So this is now negative 10 centimeters. Okay, so does that make sense? Is that the right spot? Check it out.
Is that what they got? Yep.
Yeah.
Negative 10. So
And didn't you say, Boykin, that if the focal point is, what was the focal point? It was 10?
10 centimeters.
Oh, 10 centimeters, okay.
So it's between the focal point and the mirror, and the image is behind the mirror.
Oh, yes.
So in front of the mirror, you have positive numbers. Behind the mirror, you have negative numbers.
Okay.
All right, now let's figure out how high the image should be.
Oh, I feel feel like that might be someone who's important for the keys. Hold on, guys. Hi. Oh, sorry.
Oh, there's a video. Okay, I'll talk to you about it later. Okay.
False alarm.
False alarm. All right.
Okay, so
where
now
were we?
we're going to solve for the height of the image using the magnification.
Yeah, okay, so height of the image is going to equal the negative distance of the image.
Ho-de-do.
Ho-de-do. Okay, and so let's see what we got here. The negative distance of the image, so negative 10.
And you got a negative in front of the negative 10.
Oh, thank you, sir. Boom, so like that, right? Okay, so then the dough, 5 centimeters. Dough. Okay, and then times the hoe, 2 centimeters. This is just way too much fun. This equation is the best ever.
So it's
okay.
10 times 2 is 20 divided by 5 is going to be
4?
4. And it's going to be positive 4.
4 centimeters, so...
And is that what they got? They got positive 4 upright.
So this means it's behind the mirror and it's positive 4. It's upright. Cool.
You guys understand what's going on up a hill?
So one thing, so don't get confused. The negative here means it's behind the mirror. A positive here means it's in front of the mirror because it's the
Yeah, the distance to
right?
the image, if it's in front of the mirror, it's positive, it's behind, it's negative, and
the height is being positive means it's upright, and the height being negative means it's inverted. So you
That's
have
all.
to kind of keep that in make sense in your head, okay? So a complete description of an image includes the height of the image, the distance to the image. Is it upright, inverted, or is it real or virtual?
so if this is behind the mirror and it's a negative distance to the image, that's virtual.
Oops. Okay, so virtual, it's upright, and then we have our information for height and distance on the board.
Yep.
Okay. So for your homework today, 425, numbers 2 through 4, excuse me, and they're right there. Just don't do them wrong.
Yeah. Boom.